I am Dr. Nikita Sharma, Associate Professor Chemistry, SPNKS Government PG College, Dausa. Today's topic is soaps, detergent and cleaning action of soap. Both soaps and detergents are cleansing products that we frequently use in our daily lives. We use these products to clean our skin and hence wash our clothes without really paying any attention to how they work or is there any difference between them. Although both the soap and detergents perform same action, that is cleansing, there is a significant difference between them. We can differentiate the soap and detergents on the basis of several factors like ingredients, structure, properties and more. Soap and detergent substance that when dissolved in water possesses the ability to remove dirt from surface such as the human skin, textiles and other solids. The simple process of cleaning a soiled surface is in fact complex, consists of the following physical chemical steps. First step is wetting of the surface, and in the case of textile, penetration of the fiber structure by wash liquor containing the detergent. Detergent and other surface active agents increases the spreading and wetting ability of water by reducing its surface tension, that is, the affinity its molecules have for each other in preference to the molecule of the material to be washed. Second is absorption of a layer of the soap or detergent at the interfaces between the water and the surface to be washed and between the water and the soil. In the case of ionic surface active agents, the layer formed is ionic in nature. Third is dispersion of soil from the fiber or other material into the wash water. This step is facilitated by mechanical agitation and high temperature. In the case of toilet soap, soil is dispersed in the form formed by mechanical action of the hands. Preventing the soil from being deposited again onto the surface cleaned, the soap or detergent accomplishes this by suspending the dirt in a protective colloid, sometime with the aid of special additives. In a great many soiled surface, the dirt is bound to the surface by thin film of oil or grease. The cleaning of such surface involves the displacement of this film by the detergent solution, which is in turn washed away by rinse waters. The oil film breaks up and separates into individual droplets under the influence of the detergent solution. Proteinic stains such as egg, milk and blood are difficult to remove by detergent action alone. The proteinic stain is non-soluble in water, adheres strongly to the fiber and prevents the penetration of the detergent. By using proteolytic enzyme able to break down proteins together with the detergents, the proteinic substance can be made water soluble or at least water permeable, permitting the detergent to act, and the proteinic stain is to be dispersed together with the oily dirt. The enzymes may present a toxic hazard to some persons habitually exposed. Soap and detergent ingredients. Although both the surfactants or surface active agents, that means a washing compound which mixes with grease and water, soaps and detergent are not the same thing. Soap manufacturing process is different from that of the detergent making. Soaps are usually manufactured using natural materials, while detergents are generally synthetic that were developed during World War II when there were scarcity of oils that are used to make soaps. Soaps ingredients, usually labeled as beauty, facial or cleansing bar soaps. True soaps are generally produced with natural products. Soap and lye are required very less energy in the manufacturing process. It is possible to make soaps without having leftover byproduct which tend to go to the landfill, and the soap which flows down the drain while cleaning is biodegradable. These soaps have a pH of 9.5 to 10 alkaline. This pH is alkaline that makes them effective cleaning agent and eliminate the requirement for harmful antibacterial, chemical and preservatives. However, some manufacturers use beef tallow fat in soap making, as this is an unused byproduct of meat processing which can be obtained very cheaply. While saponified beef tallow can be used to make a satisfactory soap, there are some substances in tallow which that do not saponify and may cause acne and skin breakouts. Superior quality soaps are produced with oils like palm, castor, coconut, or olive oils and retain the natural glycerin, rather removing it and selling it for profit, which bulk manufacturers generally do. Detergents ingredients. Detergents are generally made from petroleum products with surfactants, foaming agents, and alcohol being their primary constituent. To remove the disagreeable odor of these chemicals, detergents are heavily scented with cheap synthetic and artificial fragrance. Detergents ingredients also include preservatives and antibacterial agent which is increase their shelf life that make the detergent frequent cause of allergies and reactions. Soap structure. The first structure is detergent and second is soap structure. All of the soaps are fatty acid salt which can be categorized by a long hydrocarbon chain that may be monosaturated, have a double bond like sodium oleate, polyunsaturated more than one double bond, and saturated there is no double bond. Second is a carboxylate group at the end. Any surfactant or surface active agent that is not soap is a detergent. Soap detergent difference properties in hard water. The most important difference between a soap and detergent is their behavior in water. A big drawback of washing with soap is that it forms a scum in hard water which is not easy to clean and is known to turn laundry into a hue. Soaps forms a scum in hard water which is not easily to rinse away and is known to turn laundry a greyish hue. The insoluble film that soap leaves can leave a residue on the laundry, same like as would see in a shower stall where hard water is present. On the other hand, detergents react less to minerals in water, hence does not leave this residue. In case you are living in an area where the water is soft, a soap will work satisfactorily. But even then, a gradual buildup of calcium and magnesium ions, also called curd, will be left on the fabric. Another important difference between soaps and detergents in the sensitivity of soap to acidic conditions. On putting a soap into an acidic, pH is less than 4.5, it protonates the carboxylate group. The protonated soap molecule does not have a charged head and so it becomes insoluble in water. The soap molecule precipitate out there by producing a cloudy mixture of that leads to the formation of a scum. Hence, we can say soaps are not suitable for use in acidic condition. First is soaps are made from fat and alkali by specification method. Second is they are cheap. They are not suitable for delicate clothes. They are clean better in hot water. They do not produce the leather with hard water and are not able to clean the cloth. Lots of water is needed to remove soap from the cloth. Second is detergent. Detergent are carbonic compound which are not alkaline. Second is they are costly. Third is they are suitable for delicate cloths. Fourth is they clean both in hot and cold water. Fifth is they clean the cloth even in hot water. Sixth is they are removed very easily, so less quantity of water is needed. Cleaning action of soap and detergent. This is the figure. In this figure, we see hydrophilic head, aqueous solution, hydrophobic cell. Most of the dirt is oily in nature and oil does not dissolve in water. The molecule of soap constitutes sodium or potassium salt of long chain carboxylic acid. In the case of soap, the carbon chain dissolved in oil and the ionic ends dissolved in water. Most of the dirt is oily in nature and oil does not dissolve in water. The molecule of soap constitutes sodium or potassium salt of long chain carboxylic acids. In the case of soap, the carbon chain dissolved in oil and the ionic end dissolved in water. Thus, the soap molecules form a structure called micelle. In micelles, one end is towards the oil droplets and the other end, which is the ionic, faces outside. Therefore, it forms an emulsion in water and helps in dissolving the dirt when we wash our clothes. Soaps is a kind of molecule in which both the ends have different properties. First is hydrophilic end, second is hydrophobic end. The first one is the hydrophilic end, which dissolves water and is attracted towards it, whereas the second one is the hydrophobic end, that is dissolved in hydrocarbons and is in water repulsive in nature. If on the surface of water soap is present, then the hydrophobic tail, which is not soluble in water, will align along the water surface. Micelles. In water, the soap molecule is uniquely oriented, which help to keep the hydrocarbon part outside the water. When the cluster of molecules are formed, then hydrophobic tail comes at the interior of the cluster and the ionic end comes at the surface of the cluster, and this formation is called micelle. When the soap is in the form of micelle, then it has the ability to clean the oily dirt which gets accumulated at the center. These micelles remains as a colloidal solution, therefore the dirt from the cloth is easily washed away. The soap solution appears cloudy as it forms a colloidal solution which scatters light. What is the mechanism of cleaning action of soaps? When soap molecules are present in water, the molecules arrange themselves in the form of a cluster in such a manner that their hydrophobic ends are away from the water molecule and their hydrophilic or ionic ends are towards the water molecule. This is known as micelle formation. Now, the cleaning action of soaps. The dirt, oil or grease present on clothes inorganic in nature and insoluble in water. Hence, it cannot be removed only by washing with water. When soap is dissolved in water, its hydrophobic ends attach themselves to the dirt and remove it from the cloth. Then the molecule of soap arranged themselves in micelle formation and trap the dirt at the center of the cluster. These micelles remain suspended in water like particles in a colloidal solution. The various micelles present in water do not come together to form a precipitate, as each micelle repels the others because of ion-ion repulsion. Thus, the dust particles remain trapped in the micelles, which remain suspended and are easily rinsed away by water. Hence, soap micelles remove the dirt by dissolving it in water.